Welcome to the roundtable for the Society of Thoracic Surgeons Workforce on Patient Safety 2019. Proud to have Anthony Chang, Steve Harrington, John Frenzel, and Garrett Walsh here with us. We'll go around the table, we'll introduce ourselves, and then we'll get into the meat of things.
Okay, my name is Anthony Chang. I'm a pediatric cardiologist with a passion for artificial intelligence.
And I'm Steve Harrington. I'm at the Henry Ford Health System and a medical director for thoracic surgery for that program.
Kevin Lobdell from Atrium Health in Charlotte, North Carolina, and I'm involved in our regional quality education and research efforts.
My name is John Frenzel. I'm an anesthesiologist at MD Anderson Cancer Center.
Yeah, I'm Garrett Walsh. I'm a thoracic surgeon at MD Anderson Cancer Center.
Good, thank you guys. Let's start with Anthony. You have a strong interest in AI, and it's certainly important as we look to where we want to go. From your unique perspective, tell us a little bit about some challenges and opportunities.
Well, I think it's the dawning of a really amazing era in artificial intelligence, and somehow healthcare and medicine are just kind of lagging behind, although it's starting to, I think, recognize the potential benefits in the future. And I think it ranges from deep learning for medical image interpretation, which I know applies to STS in a big way, to decision support, to taking care of a lot of the mundane tasks in a hospital that cost a lot of money. As you know, hospitals spend about 15% of their expenditure a lot of times in just administration, and that's clearly too much. So I think it's a wide range of possible solutions to our sort of decades-long problems.
Yeah. As you say, a lot of work being done in imaging, and you hear things about pathology and going back in the roots of some of this, probably even dermatology.
Yes.
But specifically as it would relate to, say, cardiac surgeons, the echo, when do you think it's a reality that's commonly used where AI will be used to interpret echo and then reviewed by the cardiologist to make sure we're accurate here?
Well, it's a great question. It reminds me of a saying by Bill Gibson, who's a computer scientist, and he said that the future's already here, just not evenly distributed. So the future's already here. I mean, I'm personally working on some echo projects using deep learning. It's already here. It's already being used for interpretation. Probably 89% of cardiologists don't know that yet because we're sort of mired in our daily routine and not really thinking or looking ahead. So I think it's already here. MRIs are almost routine. I'm going to a cardiac MRI meeting in a couple of weeks, and that's all they talk about at that meeting is how do you get an AI to help make the interpretations. And I think the worry from radiologists obviously is that they'll be displaced by AI. It's actually the opposite. I actually predict that there'll be more radiologists going into the field because it'll be made more interesting because you get rid of a lot of the sort of the boring parts of your job description and start looking at the more interesting aspects of your job.
That's great. Let me ask, John, you've had some experience at MD Anderson with decision support in the way of IBM Watson, and like many of those stories, you were early on in it, and then I think some challenges along the way. Why don't you tell us some things that would be relevant, say, for our thoracic surgeons? I know they were very interested in lung cancer, and then just some pragmatic things to think about for our audience.
Yeah, I think the lesson from IBM Watson is severalfold. First of all, independent of the hype around machine learning and AI, it's still a very developmental sort of field. And so anytime you're involved in a software development effort mixed with a project that involves science and science discovery, you have a lot of uncertainty there. And so I think the combination of those two caused a lot of issues with the IBM Watson project. It wasn't a failure of the science nor a failure of the technology, but I think the intersection of those two fields became problematic. I mean, longer term, machine learning is going to really and has been transforming how we live and how we think about our patients and how we think about disease. I think getting back to what you were saying around radiology, pathology, dermatology, other sciences that are very visually based, machine learning is going to bring to the table just an absolute generational change in how we think about the disease process. I mean, right now, radiologists can only look back through several images or several studies. With machine learning, it's really just computationally limited as to how many studies you want to look back or compare to. And so being able to see disease progression across the time domain with AI is really effort independent, whereas with a radiologist it just doesn't scale. I think what we learn from this going forward is really going to change how we understand disease process and evolution.
I think for the surgeons, you'll be able to take images. I know pediatric cardiologists are starting to do that, where we sort of artificially put stents into locations and see how the geometry looks in images rendered by AI and deep learning, and before we do it on a live patient. So I think surgery is going to be done routinely with a sort of a practice run before you go in.
That's great.
To that point, I think we're almost there right now, and some things we should and could and should be doing, for example, with mitral valve repair. And we should be able to do a virtual mitral valve repair before we ever get into the operating room with the technology that we have available right now with 3D image modeling and so forth.
Yeah, there are really incredible opportunities there with virtual reality, augmented reality, 3D printing, all that sort of thing. And today we'll touch on some of that in our symposium. One real simple question is, I was contemplating this MD Anderson, IBM Watson journey. Was somewhere along the way you changed electronic health records, if I'm not mistaken, and I heard something in your discussion there that piqued my interest and related to that. And if you think about it, we're human beings, right? And we've got this medical literature, which something like IBM Watson and AI helps us work through. But a simple change like in the electronic health record and linking it to this can upset things quite dramatically. Any thoughts, comments that would be relevant with respect to that?
Well, so previous to, we installed Epic in 2016. Previous to Epic, we had a home-built electronic health record. But one of the things that we used IBM Watson for was natural language processing. And MD Anderson is a nice environment, or was a nice environment for natural language processing of notes, because we had a very stable group of providers. There wasn't a lot of flux in our faculty. There wasn't a lot of residents that were doing dictations and things like that, and we had dictations that were going back in the same system for over 10 years. And so how we talked about disease became fairly standardized. It wasn't a formal standard, but informally we spoke about disease in common ways, which made NLP very, very powerful in that environment. When we moved to Epic, we changed how we documented disease, and in doing so, made NLP much less effective. And I think that was one of the things that's kind of almost an existential thought is does the introduction of electronic health technology change how you think or conceptualize disease? Because it certainly changes how you discuss it and how you describe it.
You know, along those lines, as we migrated with the ICD nomenclature and you got increased number of choices, I don't know if you've had that experience, but sometimes it's so complex that you choose something just so that you can move on, and I'm sure that that's something that from a very practical aspect can radically change what happens with computing, right?
Well, I think in the near future, we won't be the ones that are trying to pick the code. The computers with natural language processing and even computer vision will be deciding. Because if you think about it, human beings are not very good at that, and we should let the machines do that.
Good point. Garrett, from your unique perspective, as you think about some of the things we've heard as a practicing thoracic surgeon, where do you think some of those opportunities are as we would think about safety of care?
Well, certainly in trying to, I was thinking of what we've done with natural language processing with just following up ground glass opacities, which is a more common thing that we are having to deal with, and we were able to go back and search our radiology records for ground glass opacities to try to sort out, how do we manage these patients and learn from what we've done within the institution. So from an oncology point of view, all of the points that you raised, the how we program the tumors and approach the tumors with virtual reality, that will be certainly an excellent teaching point for the residents. How we follow lesions and whether they're growing and how they're growing will save a tremendous amount of time. We're kind of transitioned to the new electronic health record, and we know that there's so much that we can glean from it, but we're at the stage where we haven't unlocked all of the full potential of the electronic record and how it can really help us in our practice. But a lot of the work that we do in the assessment of patients, the workup of patients, can become very, very, very standard, and the time that the surgeon will be able to spend with the patient will be much more focused, much more detailed, and we'll be able to select the patients that can be appropriately treated for surgery. The hope is, as well, as we expand our programs, that rare tumors or situations that are satellite institutions that an oncologist or a surgeon may only encounter a certain amount of time, that what we've learned will be able to be understood at the other institutions with an algorithm that would help them in the decision-making process and the workup, and be able to funnel those patients appropriately to the tertiary center if they're required, or keep them out in the community if that's appropriate as well. So a lot of opportunities to streamline our practice, I think, with these technologies.
In today's world, for you at MD Anderson, do you have form of decision support when it comes to planning surgery, or for that matter medical therapy, and then also enrolling people in protocols, or is that still something that lies largely in the expert's head?
Well, we're transitioning to a point that one day we would hope that the patient presents with a lesion, a type of tumor, that we'd be able to search the database, both national databases and our own protocols, to see if this patient is or is not suitable for a protocol, and it suggests certain tests. We're not there yet, but that's ultimately what we'd like to have, that sort of heads-up display that this patient is going to be eligible for this, or their genetic profile makes them suitable for this treatment. So, I think that's, with big data, that's hopefully where we're going to be able to get a personalized treatment algorithm for that patient, that we can prime the system early on at the first time we see the patient and get the appropriate test. So it's not there yet, but that's kind of what we're hoping to do.
And the University of Texas system is actually undertaking a project to bring together about 1.5 million patient records from across all of the system health-related entities. There are 8 entities that deliver health care to Texans through the University of Texas system. We're building a warehouse currently to bring that data together from the EHRs and begin to create an archive to do some of the things that Garrett's describing.
That's great. I would think that inherent in this, you'd like to be able to track what was done to them, sort of the quality and safety of that, as well as the value, right? So link it with financial outcomes, so that ultimately we know really what works and what works for the best dollars that we put into it. Let's transition a little bit to cybersecurity, which you're going to talk about today to our group in the symposium. I recently read something that was fascinating. It said 25% of these breaches come from actual healthcare workers themselves. I'm sure you have a unique point of view. Tell us some of the things that you think about on a daily basis as a Chief Medical Information Officer as it relates to cybersecurity.
So cybersecurity the cyber threat landscape has changed dramatically over the last decade. It was commonly thought of kind of like in the movies, like hackers, or some of the popular tomes of, an individual or a small group of individuals going out there and just kind of messing around on computers. With the what we're seeing today, transnational groups are systematically attacking our infrastructure, doing so with fairly sophisticated tools. Those tools are using a thing called a zero-day exploit, where there really isn't a protection against it. You can't patch your system against. And if people want to get into your system, given the backing of these governments and other entities, there's a good chance that they're going to get in, whether it's using remote sort of techniques over the network, or human techniques of paying somebody within your system, breaking into a lab and photographing your lab notebooks. It's a whole different game nowadays than it was even 10 years ago.
What do you think we can do as practitioners in the cardiothoracic space to do our part in trying to keep it as safe as possible? Very practical advice.
Well, I think, follow the rules. The things that are put in place, keep out a lot of people by changing passwords and things like that, but actually thinking about the threat in a new way, that you are a target, that your data, your information, your findings, your research, those things are of interest to other people, and the more valuable and the more interested they are in it, the more likely they are to come after it. Just practicing, good understanding of who your people are, physical security of the infrastructure and the space. Thumb drives are a constant source of loss of data. The basic things we know will help, but given the change in threat, governments are able to get at our data unlike they were able to before. Difficult to protect against.
Yeah, and to your point, I mean, we've more recently heard about even medical devices, right? It's not just the electronic health record and some of the financial, typical patient
it's the Internet of
information.
Things.
Correct.
Absolutely. Your LINAC, that's delivering radiation therapy, is connected to the network.
Yeah.
All of your radiology devices are connected to the network and get software patches and updates potentially through that network. Absolutely. Internet of Things is huge.
It's incredible. Well, I know we've only got a few minutes left. Anthony, you've been kind enough to share any closing thoughts?
Yeah, I would say we are gathering a group of clinicians that are interested in the space, technology, artificial intelligence, and I think we could use more surgeons because they're very creative, innovative people, and join the AI movement. It's really trying to transform medicine, and it's going to take a lot more work than people think, because things don't just magically appear. We have to actually create it.
Yeah, it's fascinating. It's that old, 17 years, what's the question about translation? Yep. And I think that one of the things that continues to challenge it is to make it relevant and have people from within the field lead it. So I think that there's great opportunity. I think at that point, we'll close. Thank you, Anthony, Steve, John, Garrett. It's been a great time sharing.
Thank you.
Thank you.